Exercise 98, question number 5. Uh, this question is all about the ambiguity of the angle when you've worked out what it is. So let's see how this progresses. We're going to end up with two possible answers. So let's see how this arises. First of all, I've just drawn the general triangle JKL, which is what's given in the textbook. They've used the symbols JK and L. So I've written down JK and L and put the sides in lowercase jk and L, and then written down what I'm given. So I'm given angle K, I'm given side J and side K. So I know one of the ratios. I know that side and I know the angle opposite it. So therefore I should be able to use the sine rule, knowing this side, little j, to find angle J. So that's what I'm going to do. So I'm after an angle, so let's write the sine rule with the angle on top. Sine J over side J, which is 3.85, equals the sine of the angle that I know, which is K, 36 degrees, over side K, which is 3.23. Now, as we've done before, I'm going to rearrange this little formula to find angle J. So multiply both sides by 3.85 over 3.23. And then to find the angle J, that's going to equal the sine whose angle is sine 36 times 3.85 over 3.23. So we now work out what that is on the calculator. And we get 44.8 degrees. However, there is another possible answer. Let's have a look at this sine function for a minute. Let's go back and just calculate what this part is. That fraction, sine 36 times 3.85 over 3.23. And we get 0.7006 or 0.7 to one significant figure. If we look at the sine wave from which this comes from, so this gives the values for the sines of all the angles between 0 and 360 and onwards. So if we get angles here, so this is 90 degrees, 180 degrees, 270 degrees, 360 degrees, so one complete turn, and this is the sine of the angle along here. Up here will be about 0.7. So if we go along from 0.7, we get our angle that we had before, which is 44.8 degrees. So that will be 44.8 degrees. However, if we carry on, there is another angle at which that has the sine of 0.7, and the calculator doesn't tell us that. And if we carry on, actually there are further angles beyond 360 degrees, all having the sine of 0.7. So there's an infinite number of angles actually. We're only generally interested in the angles in the first cycle, so these two here. What is this angle? Well, luckily for us, there's some symmetry here. That 44 degrees from here to here, from there to there, is the same distance as from here to here. So if this point here is 180 degrees, then if I take 44.8 degrees off 180, I will have this other possible angle here. So what is this other angle? It's going to be 180 degrees minus 44.8 degrees, which is 135.2 degrees. As a check, if you work out what the sine of 135.2 degrees is, you will get actually the same answer, 0.7. So that's proof that in fact that's another angle that does have the sine of 0.7. So going back to our original problem, J could be 44.8 degrees or 135.2 degrees. And if we go to look at the possibilities, if we draw out the triangles, either J equals 44.8 degrees, or if we look at the other scenario, J could be 135.2. And you can see that both those possibilities are there. It's feasible that side JL can be 3.23 in both triangles, and side KL could be 3.85 in both triangles, but it gives very different answers for the length of the side JK, and also for the other angle, of course, angle L. So I'll leave that at this point, and you can carry on and finish those questions to verify the solutions in the text.